Alright guys, let's try this. So see the diagram now drawn to scale. Circle P with radius 6 and Q with radius 10 intersect each other at points A and B, with point C on P and point D on Q. What the heck? Why did they draw it like this? If circles P with radius 6, so has radius 6, C is on P, so this has radius equals to 6, and this has radius equal to 10. Why did they do that? Okay. CD is a perpendicular bisector of AB. If AB cuts CD in a 2-to-1 ratio, then AB squared is equal to MN, where M and N are positive integers, no common factors greater than 1, M plus N. Okay. So my first thought here is, let's draw this again, but more accurately and larger. So we have this, and then we have this. So it cuts in a 2-to-1 ratio. Like this. Okay. So then we have this here and this here. So the first thing I'm thinking to do is to take this here and this here. Can I turn the transparency down? I don't think so. I'm going to decrease the size. Okay. So we know this here is equal to 10. This is equal to 10 minus what's the center point? Let's call this M. 10 minus C, and that's going to be CM. And then this is 1/2 AB. Then we can do the same thing here. So this is going to be, no, this is going to be 6. This is going to be, or 6 minus dm, because we want the radius minus this. And then this is 6, and then this is again 1/2 AB. So 10 squared plus 10 minus cm squared is equal to 1/2 AB squared. And again, we want AB squared, so same thing here. It's 6 squared plus 10 minus cm squared is equal to 1/2, or 10 minus dm. And then this is 6. AB squared. Okay. So, an important thing to note is that these are very similar. We can make them even more similar because we recognize that AB cuts CD in a 2-to-1 ratio. So, I think that means either CM is equal to 2-to-1. So in total there's 3. So 2/3 CM, yeah, so CM is equal to 2 dm, or 2 CM is equal to dm. I don't know which one it is. Well, presumably I'm going to do a test. If I get a really large circle and a smaller circle, no, oh shoot, and a smaller circle, intersect like this, the larger one will be on the larger side. Now let's take a equally sized circle, and can I move it in? I mean, that still seems to work. And then just barely here, but this is also smaller. So what if I take a noticeably smaller circle and move it in like this? The left side clearly has more, clearly has more, clearly has more. So it seems to me that the left side always has the larger portion. Or the larger one always has the larger portion. So we're gonna have, okay, so CM is on the, no, what this looks like, if I zoom in. This is, no, this is D, C. So dm is going to be larger. So 2cm is equal to dm. So I'll just replace this with 2cm. Okay, this seems solvable now. So now we get 100. Or if we just, this is going to be 1/4 ab squared, so just multiply by 4. So we have 4 times 100 plus 100 squared minus 20 cm plus cm squared is equal to what we're looking for, ab squared. Then same thing down here, we have 4 times 36 plus 30, this is not 100 squared, this is 36, or 100, minus 12 cm plus cm squared, no, because it's 2 cm, it's going to be 6 times 12 cm minus 6 times 12 cm, so 24 cm squared, cm, and then it's going to be plus 4 cm squared is equal to ab squared. Now we just need to isolate cm, I think. Or we could just subtract the two and then solve from there. Well, yeah, I'm just going to divide everything by 4, and then I'm going to subtract the 2. So then, that will give us 100, this is just 200, this is just 72. 200 minus 72 is 128, right? Yeah. Sorry, 120. So this will give us 128. So 200, or 20 minus negative 24, so 20 plus 24, so plus 4 cm, and then minus 3 cm squared is equal to 0. So then flip this around, 3 cm minus 4 cm minus 128 is equal to 0. So cm is equal to, use the quadratic formula. 4 plus or minus the square root of 4 squared, so 16 minus 4 times 3 times 128, but that's negative, so it makes a positive, all over 6 So take a 2 out here, take a 2 out here, and then take 4s out here. So we get 2 plus or minus over 3, the square root of 4 plus 3 times 128, which is 3 times 128 is 384, right? Yeah. 384. So 388 is this. So it's equal to 2 plus the square root of 388 over 3. 388 is 8 plus 8 is 16 plus 3 is 19. So it's not divisible by 9. Divisible by 4, it is 400 minus 12. So yeah. So it's gonna be 400 minus 12. So it's gonna be 4 times 100 minus 3, which is gonna be 97. So it's equal to 2 plus or minus 2 square root 97 over 3. 97 is not divisible by 9, not 16, not 20, or not 25, no. 36, no. 49, maybe? No. Okay. And also it's clearly plus because it's positive. I think I must have done something wrong. I see what I did wrong. I said the hypotenuse plus this squared plus this squared equals this, but it's really this squared plus this squared equals this. So let's redo that. 10 squared plus 1/4 ab squared is equal to 10 minus cm squared, and 6 squared plus 1/4 ab squared is equal to 6 minus 2 cm squared. Okay, now what we did, we could just subtract the two, so then we get 100. So this expands to 100 minus 2 cm plus cm squared. And this is 36 minus 24 cm plus 4 cm squared. Now we just subtract the two, so then we get 100 minus 30. Then we could subtract the 100, so this is 100, 100, and then this and this. So now, yeah, so now we just get, subtract the two, we get 0, is equal to 4 cm, and then minus 3 cm squared. So 0 is equal to cm times 4 minus 3 cm squared, or minus 4 minus 3 cm. So cm is not equal to 0, but cm is equal to 4 over 3. Cm is equal to 4 over 3. Okay, cool. Now we could just use this to find this. So now we just have, let's just use this bottom, or this top one here. We have AB squared is equal to 4 times 20 cm plus cm squared. Okay, so that's going to be, is equal to 20 cm is 80 over 3, so 320 over 3. And then this is going to be 16 over 9 times 4 is 64 over 9. Now just combining the two, we get 960 over 9 plus 64 over 9. That gives us 1,124 over 9. So this should be our answer. Let me go check if this is... Oh, is this divisible by 3? We know 900 is, so now we're checking 224. We know 24 is, so 200. 200 is not. Okay, let me check if this is correct. Oh wait, no, I need to add the two. Is 1,133. Should be our final answer. So I actually practically got the answer correct. I didn't actually get it correct, but it was, the only issue I did is this was supposed to be minus. And I did all the math correct other than that. So if this was minus, and then I would have gotten the correct answer. So I think I pretty much got it, because I got all of the other concepts correct, except for this just final step, I forgot the minus. Cool, thank you guys for watching, I'll see you guys tomorrow, bye.